Hi, welcome to Fun with Algorithms. In this video, I am going to talk about the most important concept to solve problems related to tree data structure. If you have guessed that I will talk about tree traversals, then you are right. But before that, I am going to briefly introduce tree data structure and then move on to traversal of trees. Now let's get right into it. Okay, let's first see what is tree data structure and some of the applications where we use it. Unlike lists or arrays, which are linear structures, trees represent hierarchical structure. One real life example is representing a family tree, say from grandfather to his children to their children and so on. Now, it looks like this. Before moving ahead, let's define some terminologies. First thing is node. It represents one element of a tree. Here we have marked it as circles. Then we have parent-child relationship. It's basically two nodes which are linked by an arrow in this picture. Node at the base of arrow is called parent and node at the head of the arrow is called child. So in relationship between nodes R and C1, R is the parent and C1 is the child. Using this relationship, you can traverse from one node to another. And the third one is if a node doesn't have any parent, then it's called a root node or root of the tree. In the picture here, R is the root node. Similarly, the nodes which doesn't have any children, they are called leaves of the tree. Here all the nodes which are marked in green are leaves. Some applications in computer science where tree data structures are generally used are, say, creating a file system or resolving dependencies such as Maven and etc. Now, in many cases, we mostly use what's called binary tree. It's just like a generic tree which we saw before, but here a node can have at most two children and hence the name binary. Now, these two child nodes are generally called as left child and right child. We also call them as left node and right node interchangeably. Both mean one and the same basically. Now, one important thing to understand is that tree is a recursive data structure. That is, any given tree is composed of smaller trees or what we call it as subtrees. So if you look at this tree, it's composed of two subtrees. First one rooted at node 4 and the second one rooted at node 7. Again, these subtrees are further composed of smaller subtrees. So we naturally tend to use recursion to traverse trees. Now that we have the basics of trees behind us, let's look at tree traversal. And here traversal basically means how we move from one node to another node and thereby visiting all the nodes of a tree and further process them. Now, there are many ways of traversing a tree, but there are four common ways in which we generally traverse the tree. They are Preorder Traversal, Inorder Traversal, Postorder Traversal, and Level Order Traversal. In this video, I'm going to talk about first three methods. I will cover Level Order Traversal in the next video. We will first look at Preorder Traversal, followed by Inorder Traversal and then Postorder Traversals. In Preorder Traversal, we first process the node as preorder indicates, and then we process left subtree followed by right subtree. In this video, whenever we visit a node, we mark it in orange, and when we process it, we mark it in red and also print the content of the node on the right side, so that order of how nodes have been processed will be clear. We always start any tree data structure problems with root node because that's the only reference we have to start with. So we start our traversal from root node 6 and we process it. Since we process left subtree before processing the right subtree preorder traversal, we move to node 4. Now we do the same thing repeatedly for all the nodes of the tree. So we process node 4 and then move to node 2, process node 2 and then move to node 1 and process it. Now node 1 is a leaf node as it doesn't have any children. So we come back up and move to the right node of its parent, which is node 3. Again, since node 3 is a leaf node, so once we process it, we go back up. Now, if you look at it, node 2 is completely processed as both left and right trees are processed. So we go further back up and we haven't processed node 4's right subtree. So we move to node 5. We continue and repeat the same process again and again till the entire tree is processed. So this is how preorder traversal works. Now, when we come to inorder traversal, we first process the left subtree of a node, then we process the node itself, and then process the right subtree. You can think of inorder traversal as something like in between the left and right subtrees. So we start with node 6, move to node 4, which is its left node, and then to its left node, node 2, and then to node 1. Now, since node 1 doesn't have any left node, we process node 1. Now, it doesn't have any right node either, as it's a leaf node. So we come back up to node 2 and process it before moving on to its right subtree, which is node 3. Node 3 is again a leaf node which doesn't have any left or right child, so we process node 3. Then we come back up to node 2. Since node 2 is already processed, we move to its parent node, which is node 4. Now we see that entire left tree of node 4 is already processed. So we process node 4 before moving on to its right subtree. We continue the same process repeatedly again to process the entire tree. So this is how inorder traversal works. Now finally, we take a look at last traversal of this video, which is postorder traversal. As post in the name postorder indicates, here we first process the left subtree followed by right subtree, and then at the end we process the node. So we start from node 6, then node 4, and so on till node 1. And since node 1 is the leaf node with no children, we process it. Then we come back up to node 2 and move to its right child now, which is node 3. Now this is also a leaf node, so we process it and come back to its parent node, which is node 2. Now, since both left and right child of node 2 are already processed, we process node 2 now. Then we move back to its parent node, which is node 4, and then to right child of the node 4, which is node 5. Again, same processing follows, and this is the way we process the entire tree in postorder traversal. So that's all about the basic traversal methods of trees. Now let's quickly go over and check the code for these traversal methods. Okay, we have this code opened in VS Code. We have two files, tree.go and traverse.go. In tree.go, I have defined a structure to represent node of a tree. It contains the node's data, which in this example is a simple integer, and references to node's left and right child. We pass this node to our traversal methods defined in traverse.go. Now in traverse.go, we have three functions: preorder, inorder, and postorder, which implement corresponding traversal methods. In our code, we use printing of node's data to represent processing of node. In reality, it could be much complex processing. In preorder method, we first process node by printing its data, and then we call preorder function on node's left and right child, which recursively process both left and right subtrees. In the inorder method, we first call inorder function on node's left child to process the left subtree, then process the node by printing its data, and then we call inorder function on node's right child to process the right subtree of the node. Similarly, in postorder method, we first call postorder function on node's left and right child to process both the subtrees, and then process the node by printing its data. So as you see, implementation of these tree traversals are very simple. So that's all about the basic tree traversal. Hope you have enjoyed the video. And if you like the video, please do like, comment, share and subscribe. And don't forget to press the bell icon to receive notifications on my new videos. See you next week. Thank you.